Hello everyone, my name is Abhi. I work as a security consultant for Security Compass San Francisco. Today I'm here to talk about a special kind of race conditions in web applications called time of check to time of use, often known as TOCTOU. I'll also be introducing an open source project called OWASP TimeGap theory. Let us look at the plan first. I'll give you the story behind OWASP TimeGap theory. I'll also introduce OWASP TimeGap theory. It is a capture the flag style intentionally vulnerable application. I'll walk you through some of the challenges. I'll tell some of the interesting stories related to TOCTOU. I'll give you links so that you can go back home and check all these things yourself. By the time we complete this mini training session, you will be a TOCTOU champion. That I can promise. Let me tell you a story. I work as an SME for threat modeling sessions. My day-to-day job involves sitting in threat modeling sessions and telling people what to do. Once I was in such a session, I looked at a particular design of the software and I was like, looks like this is vulnerable to TOCTOU. Most of the people sitting in that room did not know about TOCTOU, so I had to explain. Imagine this, you are going for a movie. You wanted your favorite seat, so you decided to book the ticket online. You went to the website, checked the seat is available. Looks like you're lucky the seat is available. You want to book the ticket and you have entered your credit card information and everything. You clicked on the final book now button. You are expecting a success message saying that the seat is booked, but you get an error message instead. It says the seat is already taken. There was a time gap between the moment you checked the availability of the ticket and you entered the final book now button. You had to enter your credit card information, other contact information, etc. Within that time, someone else booked that ticket. These type of things happens all the time. It can happen while you buy stuffs online, when you try to book an airline ticket, or when you try to purchase face masks thanks to COVID-19. What if both of you click on the book now button together at the same time? Is the application going to prioritize one request over the other? Is the application going to cancel both of the requests? Is the application going to honor both of the requests? If yes, both of you will get same ticket for the same seat for the same show. Now back to my story. Most people in the room did not believe that this is possible. Many of them knew about TOCTOU. They said TOCTOU attacks are very hard to exploit. Almost all database technologies have some sort of preventive mechanism against these type of attacks. Over the next few months, I came across multiple such occasions. I wanted to shout out to the world that TOCTOU issues are real. But how? I asked myself. In order to make it easy for people to understand about TOCTOU issues, I came up with this project called OWASP TimeGap theory. It is a capture the flag style application. It has 7 challenges now. It's free, open source, and yes, it is Dockerized. You can also run it on Heroku if you want. The homepage of OWASP TimeGap theory looks like this. The score page is where you can see all the progress. The web app directory is where all the challenges are. Let us start with the first challenge, which is the sign up page. A high-level user flow for the sign up page would look like this. User enters their email ID and password. The application will check on the database to see if that email address or username already exists on the database or not. If a match is not found, the application will create a user account. If a match is found, then the application will throw an error message instead. Let us go to the sign up page and see this in action. There are 4 buttons on top. You can click on them to fill the form automatically. This way you don't have to manually enter email address, password, and the username by yourself. First, click on the Tom button. The application will fill the user details for Tom. Click on the Submit button. It will create a user account for Tom. Repeat the same steps, and you can see that the application is not letting you create a second user account with the same details. We need a way to speed up these requests. Well, either we need to speed up the request or make the application go slow. That is where the bullet time feature can come handy. Go to the settings page and put a value like 5 seconds into the main wait field. To make it easy to trigger 2 requests, open 2 browsers side by side. If you don't have 2 browsers, you can use a normal window and a private or incognito window. Let's click on the Jerry user button this time on both the browsers. Click on the Submit button as fast as you can on both the browsers. Wait for the request to finish. It will take slightly longer time for the browser to finish loading because of our bullet time feature. It looks like both the requests are successful. If you go to Admin Manage Users, you can see that there are 2 users with the same email address. If you go to the score page, you can see that you have gained 100 points for solving the first challenge. All these looks good in theory, but in real life, you can't expect somebody to slow down their server so that you can exploit TOCTOU issues there. You can wait for the peak traffic period or launch a DDoS attack against the application to achieve a similar effect, but we need something better. Let us see a different way to exploit TOCTOU issues. Go to the sign up page, then fill in the user details for any of the user, open Browser DevTools and submit the form. Go to the Network tab of the Browser DevTools, then look for a post request to sign-up.php page. Right click on that request and copy that request as a fetch request. Go to the Console tab of the Browser DevTools and paste that particular request. We need to modify the parameters a little, so let's change all of them to DevTools. This is just one request. We need multiple requests. For that, copy paste the same request multiple times, all separated by a comma. Press the Enter key once you have completed it. Go to Admin Manage Users and you can see that your attempt is successful. You have 2 more accounts with the same email address. What is the use of such an attack? Why should an attacker or a user bother about creating 2 user accounts with the same email address on the system? The motives can be many. Maybe they want to fool the audit trail. An attacker may also try to sign up for multiple accounts with the same email address, an email address belonging to a legitimate user. If a user clicks on the verification link, any of the verification link, and completes the sign up process, maybe the attacker will get a permanent backdoor to that particular account. Just by designing this challenge, I proved 4 points. 1. TOCTOU issues are real. 2. Not all databases can prevent these type of issues by default. You need to carefully design the application to prevent TOCTOU attacks. 3. You don't need sophisticated tools to perform TOCTOU attacks. Just a modern browser with DevTools is more than enough to perform basic TOCTOU attacks. 4. TOCTOU attacks are not just about money transfer pages. It can affect other pages as well. If you go online now and search for TOCTOU issues, race conditions in web applications, or concurrency issues, you'll see tons of articles talking about different stuffs, and out of them, a lion's share would be talking about money transfer pages. So here I am proving a point that TOCTOU issues can affect other pages as well. Now back to my story. After designing the first challenge, I asked myself, have I done a good job? What if in future people say, hey, TOCTOU issues are real, it can affect money transfer pages and sign up pages, but nothing else. I don't want that. That's why we have the second challenge called login page. Login pages are simple. You enter your username and password or email address and password, submit the form, the application will match whatever you have entered with what they have on the database. If a match is found, it will create a session. If a match is not found, it will throw an error message instead. In addition to the typical design, our login page has one more additional feature. Every time a user enters a wrong password, the application will start counting the failed attempts towards that particular email address. Once the failed attempt count has reached a particular threshold, the application will lock down that account. This is a plain and simple technique to prevent brute force attacks. Let us check this behavior by going to the login page. Click on the user button Tom and change the password a little and press the submit button. Keep doing that few times and you'll see an error message saying that the user account is logged out. Now click on the Tom button and submit the form again, and you'll see that even if you supply the correct credentials, the app won't let you in since the account is logged out. Now that Tom's account is logged out, let us see if we can find the password of the user Jerry by performing a brute force attack. Open up Browser DevTools, go to the Network tab and copy a request that is going to the login page and copy that request as fetch. Open up Browser DevTools, go to the Network tab, copy the request that is going to the login.php page, the post call to the login.php page, copy it as fetch, go to the console tab, paste that particular request, paste that request multiple times, say 5 times, all separated by comma, change the password in the initial for request to an incorrect one, and on the last one, put the correct credentials. Now click the enter button. In the real world, you may use a dictionary or a word generator for creating these passwords, but just for this demo, we will go with passwords typed as it is. Looks good. Let's clear everything up on Network tab, then go to the console tab again, press the enter button. Go back to the Network tab, go through all the requests that is going to login.php page and find a request that has 302 response, which indicates a successful login. If you click on that, you can find the correct password. If you want an established session, click on the index.php page right after that 302 response and open it in a new tab. We just bypassed a brute force mechanism by exploiting TOCTOU. You can solve this challenge using the bullet time feature as well. For the record, it is not just login pages. Any page that has similar rate limiting design can be potentially vulnerable to TOCTOU attacks. Did you know that people used to believe PHP applications wouldn't be vulnerable to TOCTOU attacks? I heard the idea behind that thinking is that PHP by itself doesn't allow multiple threads or concurrency operations. However, the platform it runs on, Nginx or Apache, they allow concurrency. Because of that, PHP inherits TOCTOU issues from the platform it is running on. When I first started developing TimeGap theory, I used Node.js and Express.js to create the challenges and everything. Then I asked myself, am I making the right choice here? What if somebody says the TOCTOU issues are platform dependent or language dependent? I didn't want that. I wanted to tell people that TOCTOU issues are not platform specific. To prove that point, I rewrote the code in PHP. Let us go back to the challenges. An actual money transfer page this time. Money transfer scenarios has been friends with TOCTOU issues for a very long time now. Almost all the articles out there talking about TOCTOU issues talk about money transfer pages. In today's session, we are paying a tribute to that age-old tradition by having a transfer rewards points page. The working of a money transfer page is simple. There'll be a sender and a receiver. The sender sends money to the receiver. If you look at the data flow diagram, you can see that there's a check that is happening for every transaction. The application checks whether the sender has enough money before performing the transaction. Say, for example, if Tom tries to transfer 30 points from their account while they have only 10 points in their account, the transaction won't go through. As security people, we shouldn't be believing the claims from an app developer. Let us verify that by ourselves. Log in as any user by going to the login page. Click on the transfer rewards button. It will take you to the transfer rewards page. Then click on the first button to fill up the form automatically. Then change the transfer amount to an amount that is bigger than the current balance on the account. Click on the transfer button. You will see an error message saying that you don't have enough rewards. So the check is actually happening. Let us go back to the data flow diagram. If you look closer, you can see that there are two steps the application performs during a transaction. Right after the balance check, if the user has sufficient balance, then the application reduces that particular amount from the sender, then it adds that particular amount to the receiver. If you can send multiple parallel send requests to the application within a small time frame, or if it is parallel, before the application starts reducing the value from the from account, you may get lucky. Let us try that. Go to the Manage Users page, select the user Jerry and set 0 as the reward points on Jerry's account. Go to Tom's account and set 100 as the reward points on that particular account. Go to the settings page and put a time delay like 5 seconds as in the main wait field to enable the bullet time feature. Open two browsers side by side. Go to the login page and log in as the user Tom on both the browsers. Navigate to the transfer rewards page. Click on the first button to fill the details automatically. Put Tom as the sender, Jerry as the receiver. Put the amount as something slightly lesser or equal to the current balance on Tom's account. Click on the transfer button on both browsers as fast as you can. Wait for both requests to finish. Now go to admin manage users. You can see that Jerry has more rewards than what Tom had initially. So you basically made reward points out of thin air. Just so that you know, you can solve this challenge using browser dev tools as well. The steps would be similar to the sign up and login challenges. Did you know that Starbucks had a similar TOCTOU issue back in 2015? All you had to do was purchase few gift cards from Starbucks, then keep on transferring the money between those gift cards within a short period of time, as many times as you can. If you are lucky, you will get cash in your account out of thin air. It's not just Starbucks, by the way. If you Google for TOCTOU issues, race condition issues, or concurrency issues in web applications, you'll find a lot of these type of bug bounties reported in various firms all over the globe. Race conditions and TOCTOU issues were never in OWASP top 10, but that doesn't mean that you can ignore them. Hopefully, OWASP TimeGap theory will help people understand this particular security issue and encourage people to build defense on their applications. The next challenge is kind of a science fiction. The name of the challenge is Ticket to Mars. Think of TimeGap theory as a prosperous company. They are giving out Ticket to Mars if you have 2000 reward points by the end of the year on your account. Let us see how that works. Go to the admin and click on Create Default Users button to reset the database and create some sample accounts on the system. go to the admin manage users page, and you can see that Tyke is the only user who has at least 2000 reward points in their account. Now, assume that it is the end of the year. An automated script will check balances on all of these accounts and determine who is eligible for gaining that ticket to Mars. You don't have to wait for the year end to trigger the script, by the way. You can go to admin and click on Ticket to Mars button to trigger that particular script. Let us do that. You can see that the script has determined Tyke as the only user who's eligible to get the ticket to Mars. Now, how Tyke can gain the system so that he can go to Mars along with Tom? First, log in as Tyke and transfer all reward points to Tom's account. Go to the settings page and add 5 seconds delay in the Mars wait field to enable the bullet time feature just for the Ticket to Mars program. Open two browsers side by side. On the first browser, navigate to the admin. On the second browser, log in as Tom and pre-fill the data as set sender as Tom, receiver as Tyke, and put 2000 reward points as the transfer amount. On the first browser, click on the Ticket to Mars button, then go to the second browser as fast as you can and click on the transfer button. Wait for both the pages to load. On the first browser, you can see that Tom and Tyke got the ticket to Mars. What exactly happened here? Let us look at the flowchart for this particular operation. If you look at the flowchart, you can see that the application goes through the entire list of users and check if they have enough reward points or not. If the user has at least 2000 reward points, it will assign a ticket to the Mars for that particular user and will go on to the second user. There is a time gap between the first user check and the last user check. If you can transfer money from the first account to the last account within that time, both of them will pass the check and both of them will get the ticket. In a real world scenario, attacker will be knowing the execution time of that particular script. Say for example, midnight on December 31st. So they may schedule the transaction to happen exactly at that time to make it easy to exploit this particular issue. Do you know that race conditions in life critical systems can be dangerous? In 1993, 3 people died and several people got injured due to a race condition issue in a radiotherapy system. The Northeast blackout of 2003, which was a wide power outage in US and Canada, was also caused by a race condition bug. Do you want to know how you can set up a home lab of OWASP TimeGap theory? Having a home lab can help you understand TOCTOU issues much more closer. It can also help you teach about these issues to others. The first and recommended option is to use Docker. Install Docker, then clone this particular GitHub URL or download the zip file and extract it. cd into timegap-theory directory, issue the command docker compose up-d. Go to your browser, navigate to localhost, and you will see the home page of OWASP TimeGap theory. If you don't want to use Docker for any of the reasons, you can go for the Heroku version instead. First, sign up for a Heroku account and activate the account. Activating the account requires you to confirming the email and setting up some payment information like credit card. It is just for activating the account, by the way. You don't have to spend money for actually running the OWASP TimeGap theory lab. Once completed, go to the GitHub page of OWASP TimeGap theory, click on the deploy button, follow the on-screen instructions, and you'll have the lab ready. I'm sure all of you are familiar with rating systems. Facebook, Instagram, YouTube, Google Maps, all of them have some sort of rating system. It can be like, love, or a full-fledged 5-star rating system. There is one business logic of rating system that many people doesn't like. They can only like or love a particular post or video once, not more than that. I'm here to bring your attention to a new idea. What if you can like a particular post or video 100 times. Do you like that idea? Let us see how exactly we can do that. To achieve our goal, we need to understand how a rating system works. When a user clicks on the like button, the application will check the database to check if that user already liked that particular post or video before or not. If a previous instance is not found, the application will create one. If a rating is found already on that particular post from the same user, they may remove it or they may do nothing. Let us check if the application is performing these checks or not. Go to the login page and log in as any user. Navigate to the ratings page. You will see a message saying that you have no ratings. Click on the love button. You will see a message saying that you have 1 rating. Click on the love button again. Now you will see that the message has changed to you have no rating. The application has removed our initial rating when we clicked on the button again. Navigate to the admin page and click on create default users button. Then go to the settings page, set 5 seconds as the main wait delay to enable the bullet time feature. Open 2 browsers side by side. Log in as same user on both the browsers. Navigate to the ratings page on both of the browsers. Click on the love button on both the browsers as fast as you can. Wait for both the requests to finish. You will see a message saying that you have 2 ratings. Now, let us see how we can automate this. First, we will use browser dev tools for automating this. Pay close attention this time because you are not going to like the final outcome. Go to the settings page and disable the bullet time feature. Go to the admin and click on create default users button. Go to the login page and log in as any of the user. Then navigate to the ratings page. Open browser dev tools, then click on the love button once. Click on the love button again to remove the existing rating. Go to the network tab of the browser dev tools. Click on the post request to the ratings page, right click on it and copy it as fetch. Go to the console tab of the browser, paste that particular request several times, all separated by comma, then press the enter button. Our attack failed. What exactly happened here? There are 3 things we should pay attention to: CSRF prevention tokens, cookies, and sessions. First, CSRF prevention token. Let us see the blocking parameter is CSRF sessions or not. Click on the love button multiple times, then inspect all these posts called to the ratings page by going to the browser tools and network tab. Observe the pattern or behavior of the CSRF prevention token that is being supplied. Looks like it is not being changed. So that is not something that prevented us from executing the attack properly. Second, cookies. Fetch requests are not capable of sending cookies to the application. So we need a mechanism to send cookies to the application. We can use curl. Curl supports sending cookies to the application. The third thing, sessions. Now that we have sessions, PHP can look for requests coming from the same session and execute them one by one. This can prevent TOCTOU issues from being successful. In all our previous challenges, the pages were not authenticated, so the sessions were not important. But now that the ratings page is authenticated, we have to be careful about sessions as we can create multiple sessions easily, by the way. You just have to log into the application from different browsers and you'll get multiple sessions. We need 2 curl requests. Let's obtain the first one now. Log in as any user. Navigate to the ratings page. Now open browser DevTools. Click on the love button. Go to the network tab of the browser DevTools. Look for the post request that is going to the ratings.php page. Right click on it and copy as curl this time. We have the first request now. Repeat the same steps on a different browser to get the second curl request. Open terminal, paste the first curl request, space, ampersand symbol, space, second curl request, and press enter. If you are on Windows, you need a slightly different request for this, by the way. Also remember to remove the compressed parameter from the request to make it widely compatible. Go to the browser window, refresh the page, and it says you have 2 ratings. Let us look at some of the tools. Among these tools, Raise the Web is my personal favorite. Raise the Web is developed by Aaron, who's a former colleague of mine in Security Compass. You should check out his Hackfest presentation because in that, he discusses about preventive mechanisms against TOCTOU issues. First, you need to get the Raise the Web binary from the GitHub page of the rest of the web tool. In order to run the tool, you need to create TOML files. Let us look at a sample TOML file. This is the TOML file for the transfer rewards page. Count defines how many requests the tool needs to send to the application. Verbose defines the verbosity level of the output shown on the screen. The method defines the type of the request. It can be get, post, put, delete, etc. URL is, well, the URL at which the request needs to be sent. Body of the request is important if you want to send a body as part of the request. If you don't need this part, you just ignore it. Once the TOML file is ready, you can supply it to the rest of the web tool and execute the attack like this. Do you know that OWASP TimeGap theory is a team effort? These are the people who were involved in bringing this project to you today. We have also released a book. You can get it from timegaptheory.com/book.html. The physical copies cost you around $30, but you can get the soft copy for free from the website. I will highly recommend getting this book. This way you'll have a handy guide with you all the time, which you can refer later if you want to understand more about TOCTOU issues. It can also help you to teach others about TOCTOU issues in general. Thank you for attending this session. All our efforts will go waste if nobody uses this product or nobody learns anything from it. As early adopters for this project, we thank you from bottom of our hearts. If you have any questions, please reach out to us using the contact form, our Slack channel, or in our subreddit. I have also written a TOCTOU poem. Let me recite that for you. What I need to do today is to find a gap in time that no one thought, a flaw in time that no one caught. What I need to find today is to find some variables that thread by threads, variables that not yet locked. What I need to do today is to find some gap in time, from the tick of time of check to the click of time of use. Thank you.